B, C, D, E, F, G, H, I, J, K, L, M, N, O, P.
So, good morning, class.
Good morning, sir.
I'm hoping you're doing great. Today is October 24th in the year 2022, and it's exactly 10 a.m. in the morning, and we are on air in studio. Join me, this is Teacher George. With me here is two students, Willie and Nathan.
A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P.
So, today we are going to introduce a new topic, magnetism and magnets. And I'm very sure that you have come across these two terms, that is magnet and magnetism. I know if I ask a question about these two terms, or maybe what do you understand by these terms, maybe you can just give a recap of what you know, and that will be it. So Kirui, can you give us can you give a trial of what you understand by the term magnet?
Okay, sir. The way I understand what a magnet is any material which attract any other materials.
So very nice, Kirui, you have given us a nice definition of a magnet. So what is a magnet? What do you understand by the name or by the term a magnet? A magnet, this is an object which experiences attraction and repulsion. So also we are going to define the term magnetism. Can anyone give us the leakage or the preview of what you understand by the name magnetism?
Magnetism is that property of a magnet to attract objects to itself.
So that was a nice trial, Kevin. So the actual the actual definition of magnetism is it is a physical phenomenon produced by the motion of electric charge, which results in attractive and repulsive forces between objects. So that was very nice of you, my students. Now we are going to move to the next slide, or the next part of the topic, and now we are going to start with the properties of a magnet. We are going to start with what? Properties of a what?
Of a magnet.
Properties of a magnet. So we can start by stating the first property, or we can just start with a little introduction about the properties of a magnet. So these properties, they are like the characteristic of a what? Of a magnet. So we can just start by understanding, as we had stated, by understanding the term magnet. So we can say, so in the previous definition of a magnet, we said a magnet, this is an object which attract what? Which attract or repels an object. So in this subtopic of the properties of a magnet, we are going to first understand the term poles. So a magnet has two poles. A magnet has two poles. That is the North Pole and the South Pole. The North Pole is located. So as I was saying, the North Pole is located at one end of the magnet, and now the South Pole is located at the other end of the magnet. So, and since these 2 points, the North Pole and the South Pole, are located at the end of a magnet, we can say that the forces of attraction are stronger at these poles. So this can be illustrated experimentally using iron filings, whereby we can sprinkle our iron filings on a magnet, on a bar magnet, and we tend to find out that these iron filings are highly concentrated at these ends of the poles. So in our next lesson, we will go to the laboratory and illustrate this property experimentally, so that we can see what happens in the poles. Now let's move to the next property of a magnet. The second property of a magnet is the directive property of the magnet. This property talks about mostly about the direction of a magnet when it is freely suspended, and it is observed that when this magnet is freely suspended, it always points in north-south direction. This can be demonstrated with the help of a simple activity, which will maybe we'll maybe look at it in the next lesson. So in this property, which is directive properties of a magnet, we can give an example of our planet Earth, which also shows this kind of a magnetism property. The Earth is actually a giant bar magnet with its magnetic pole toward the geographic south pole and the magnetic south pole toward the geographic north pole. We observe that our Earth is tilted. For those who did geography, we can see that the geographers observe that the Earth is always tilted in an angle. So hence we can observe the north pole of a freely suspended magnet points toward the north pole of the Earth, and the south pole of the Earth is freely suspended magnet points toward the south pole of the Earth. Students, I think now you got the idea of what we mean by that second property of a magnet, which is the directional property. We now move to a third property of a magnet, which is the repulsive properties of a magnet. In this property, we will see that like magnetic poles repel each other, and unlike magnetic poles attract each other. This property coincides with the basic law of what? Magnetism, which we'll have to look at it in our next subtopic. So these properties of attraction and repulsion exist between two magnets. It can be demonstrated with the help of a simple activity, which we'll still look at it in our next lesson. So let's look a little bit deep in this third property of repulsive property, or repulsive property of a magnet. So we said, like magnetic poles repel. For instance, when you take a magnet, two bar magnets, you bring together the north pole and the south pole together, close together. You will notice that there is that small force, which is a repulsive force. In the same case, when you bring the north pole, now we said of the south pole, so when you bring the north pole together, you will also observe that they are doing what? They are repelling. They are repelling. So that is the third property of a magnet, which is repulsive property of a magnet. So having discussed about the properties of a magnet, we are now moving to our next subtopic, which is the basic law of magnetism. So initially, in the ancient time, that is back in the 16th century, or the 17th century, some scientists tried to come out with this basic law, and one of the most known scientists is the Michael Faraday, whereby they came to a suggestion, that is, with a junction of scientists, they came to a suggestion that that contributed to this basic law of magnetism. They tried to convince us on how these magnets behave. So they came up with this suggestion that, like poles attract and unlike poles does what? Unlike poles repel. So that comes to a conclusion to this basic law of magnetism, which states that the like poles of a magnet the like poles of a magnet repels, and the unlike poles of a magnet does what? Attracts. So this law of magnetism was derived from the previously discussed properties of a magnet, which are the attractive properties of a magnet and the repulsive properties of a magnet, which we had already discussed, and I know you already know how we stated them. So students, I hope you got the idea, or you got the ideal rule of magnetism. Now we move to our next subtopic, which is the magnetic field, or the magnetic field what? Field lines. So we start by the definition of this term so that we can get the whole idea of what we are talking about. So we say, as I remember, as we were starting, we gave the definition of magnetism, and we had this term, magnetic field. So let's explain this term. What do we understand by the name magnetic field? Magnetic field is the area around the magnet where the magnet impact or the magnet force is felt. You get? This is the area around the magnet where the magnetic impact or the magnetic force is felt. So for this magnetic field to be felt, there are some imaginary lines which we usually use to demonstrate this electric field, and we call these imaginary lines as magnetic field lines. These magnetic field lines definitely consist of or we have some of their properties which will help you maybe to demonstrate that in a book. And one of these property is that these magnetic field lines sorry. These magnetic field lines originate from North Pole to the South Pole. So while demonstrating these magnetic field lines maybe in a drawing or in a chart or in a book, you should make sure that these field lines which are moving from North Pole to South Pole, you should make sure that you put or you draw arrows on them which demonstrate these lines or which demonstrate the direction of these magnetic field lines. So the other property of this magnetic field line is they never intersect each other. This means that this line are always parallel. They are always parallel to each other, so they never touch each other. So the third property of these magnetic field lines is they are close near the poles or near the origin of them. The origin where they originate, they are very close. Compared to this, they are moving from north to south, so they are moving from north to south, so they are concentrated at the poles. At the middle of the magnet, they are a bit spaced, and then they join the other end of the magnet, that is the south pole, and you find out that they are more close to each other. So basically, we have looked, that was the basic information about the magnetic field and the magnetic field lines. So we can now move to the magnetic materials and the non-magnetic materials. Students, I know since you are born, you have come across a magnet, I know. So I think you should be able now to maybe have a clue of what magnetic materials are and non-magnetic materials are. So basically, I want one of you students to tell me what you understand by the term or what do you know or what do you understand by this term magnetic materials.
Magnetic materials are the materials that when placed next to a magnet, they are attracted to it.
That was a very nice trial. It is a very nice. Actually, it is a very good trial. You can clap for him. That is very enough. And so he said, magnetic materials. These are materials which are attracted. Magnetic materials. These are materials which are attracted by a magnet. We now get to the other term, which is the non-magnetic what? The non-magnetic materials. So, anybody who can tell us what are non-magnetic materials? Kirui, can you tell us what are non-magnetic materials?
Okay, teacher, what I understand by the term non-magnetic material is these are materials which cannot be attracted by the magnets.
Oh, very nice. These are materials which cannot be attracted by what? By a magnet. That was a nice try, Kirui. So we can now basically get the ideas of what we mean by these terms, magnetic materials. And I think that topic was enjoyable. So right now, we can give the examples of maybe magnetic materials. We can give examples of non-magnetic materials. And maybe Professor or Brian, can you tell us one example of a magnetic material? Brian, can you tell us one example of a magnetic material?
One example of a magnetic material is iron.
Very nice. It is iron. Iron is a good magnetic material. Another magnetic material.
Nickel.
Nickel is another good magnetic material. So right now we'll now move to I have come across this question mostly, which deals with the polarity. We have looked about the polarity of the polarity of a magnet. That is the poles. There is this question which is always tested, that which is the surest way to test the polarity of a magnet. So I want one of you students to tell me which is the surest, or to give a try of which is the surest way to test for polarity of a magnet. Or instead of doing that question right now, go do research. I'll give you that question as an assignment. So that question should be, you should submit it in our next lesson as an assignment. So we now look very fast. We now look at the types of magnet because of time. So there are several types of magnets. One of these type of magnet is a bar magnet, and the other type of magnet is a horseshoe magnet. These are the two major types of a magnet. As we come to the end of our lesson today, we have covered a bit of content in this topic, magnetism. We have defined what is a magnet. We have defined magnetism. We have stated the properties of a magnet, the types of a magnet, the basic law of a magnet. We have also looked at how to draw the magnetic field lines. We have talked about the magnetic fields, and also we have looked at various types of magnet, that is the non-magnetic and the magnetic materials. We have also differentiated between a magnet and the magnetic materials and non-magnetic materials. So that basically has bring us to the end of our lesson today. So student, any question? I think any question?
Sir, Can you please give us another example of a non-magnetic material?
Okay, so that is a very nice question, Kirui. Of course, there are other examples of non-magnetic materials, which may include rubber, plastics, stainless steels, feathers, papers, gold, leather. Actually, there are many sorts of non-magnetic materials. Go do research and maybe you can get other more examples on magnetic materials. And so far so good. I think now we can we have come to the end of the lesson today, and I really enjoyed your company. You really cooperated. See you in the next radio lesson. You are good students.